All right, so today we're going to talk about lesson 8-8, distance in a plane. Using the Pythagorean theorem, the distance between any points in a plane can be found if you know their coordinates. Okay, so as long as you know two coordinates, you can find the distance using the Pythagorean theorem. Distance along vertical and horizontal lines. There's an easy way to do it when you have distance along vertical and horizontal lines. To find the distance between any 2 points in the coordinate plane, we begin by examining the situation where points are on the same vertical or horizontal line. So an example, these 2 points are on the same vertical line. These 2 points, D and E, are on the same horizontal line. You can find the distance between 2 points on the vertical or horizontal lines by thinking of them as being a number line. The distance can be attained by counting spaces or by subtracting the appropriate coordinates. Consider the rectangle DEFG graphed on the next page. Here's the graph right here. It's not on the next page. As I said before, G and F, they're on the same horizontal line. Horizontal distance, DE, which is right here, can be found by counting the spaces on the number line So the spaces on the number line, or it can be calculated by subtracting the x coordinates. So if you have horizontal distance, you're going to subtract the x coordinates. So it's a -2 minus 3. Now, it's always an absolute value. Why is it always an absolute value? Because distance is always positive. Okay? Distance is always positive. Going from somewhere to some other place, you always have positive distance. So in this case, it's a -2 minus 3. -2 minus 3 is a -5. The absolute value of a -5 is a +5. Vertical distance. As you should notice from horizontal distance, you go left to right. -2 minus 3. Vertical distance. The distance EF can be found by counting spaces, or it can be calculated by subtracting the y coordinates and taking the absolute value. Okay, so here E to F, you take the y coordinate minus the y coordinate of this one. So you go from top to bottom. So it's 3 minus a -1. 3 minus a -1. A negative and a negative is a positive. So 3 plus 1 is 4. The absolute value of 4 is 4. So that's a very easy way you can do horizontal distance and vertical distance. Not always are we going to have 2 points that are on vertical and horizontal lines. Let's look at Quiz Yourself 1. Find the length of the segment whose endpoints are 50, 21 and 50, 46. Well, if you think about it, 50, 46 is above 50, 21. So since these two things are the same, top subtract bottom, so the absolute value of 46 minus 21, 46 minus 21 is the absolute value of 25, which equals 25. Okay? As I said before, the distance between any 2 points in a plane, the Pythagorean theorem enables you to find the distance between any 2 points in the plane. Okay? If you're able to do that by counting. Let's look at example 1. Find AB in triangle ABC at the right. So they want us to find AB, which I'm just going to label as C, because that is my side opposite of my hypotenuse. Well, if you look at this, the distance from A to B, or A to C, sorry, the distance from A to C is how many units? Well, it's 1 minus 8. So it's the absolute value of 1 minus 8, which is a negative 7, which we know is a positive 7. And the distance from 5 to 2, well, we can easily count this 1, 2, 3, or the absolute value of 5 minus 2, which is 3. So these are my legs, 3 and 7. My hypotenuse is C. Okay? So C squared equals 7 squared, which is 49, plus 3 squared, which is 9. So C squared gives me 49 plus 9 is 58. And we know now C, take the square root. That's my exact answer. If I want an approximate answer, the square root of 58 is equal to 7.61. What happens if our lines are not such a way that we can sit here and count these or determine those? The formula for distance between 2 points. If you're given the distance or want to find the distance from A to B, you know A is x1, y1, B is x2, y2. To find this distance, you're going to use the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Okay? Very important piece of information. This is to find the distance between any 2 points on a coordinate plane. Let's look at example 2. Find the distance between the points. I'm going to label this x1, y1 because that's the first point I came to. I'm going to label this x2, y2 because that's the second point that I came to. It says to the nearest thousandth, so we're going 3 decimal places. So if you remember our formula, x of 2 minus x of 1 squared plus y sub 2 minus y sub 1 squared, okay, is going to find our distance. So I'm going to plug those numbers in. x2 is 31 minus 23 squared plus y sub 2 is a negative 11 minus y sub 1 is 16 squared. 31 minus 23 is 8. 8 squared is 64. A negative 11 and a negative 16 is a negative 27. If I square that, it's going to give me 729. Okay, there's my math right there. Negative 16, negative 11 minus 16, negative 27. Square it, 729, just for you to know. Now I'm going to take and add 64 to it. Gives me 793. So that's going to be my exact, my approximate square root of 793 is 28.160. I just want to show you that again. 28.160, 3 decimal places, is the distance from this point to this point. Let's look at example 3. It says use the map at the right. It shows streets and locations of 3 buildings in a city. The streets are 1 block apart. Give the coordinates for all 3 buildings. Well, this is obviously 0, 0. This is a negative 5, 2. My art museum is a negative 3, negative 5. Okay? So we did all the coordinates. B says find the distance from the train station to the zoo. So we're looking for this. I'm going to call this my C. Why am I going to call this my C? Because this right here is going to form my right triangle, okay? And therefore, that is my hypotenuse, okay? Well, what's the distance from here to here? Well, the distance is 5 units. What's the distance from here to here? It's 2 units, okay? So I'm going to use the Pythagorean theorem. I'm not going to use, when you have small sides like this, I would use your Pythagorean theorem. I wouldn't go ahead and use the formula that I just showed you a minute ago. But I'm going to show you that both of them are going to work out. So, C squared equals 5 squared plus 2 squared. C squared equals 25 plus 4. C squared equals 29. So C is the square root of 29. So C equals, we go out to 2 decimal places, square root of 29, you're going to see here is 5.385. 5.385. What if I did it the other way? Well, I would have to label this x1, y1, label this x2, y2. So it's 0 minus a minus 5 squared plus 0 minus 2 squared. Well, 0 minus a minus 5 is a plus 5. Gives me 25 after I square it. Negative 2 squared is 4. Gives me the square root of 29, which we all know equals 5.385. So both ways work, okay? And that's all I have for you today. Hope you enjoyed distance in a plane. We'll see you next time.